Hi, this is Pratik Bhatia and you are watching a video session on beginning with SQL. SQL stands for Structured Query Language and it is used to retrieve the data from the database. The process of requesting the data and to get back the results from the server is known as query the data. And to query the data, we use a language known as Structured Query Language. In this session, we will discuss the basics about SQL. Let's start this session.
SQL is a non-procedural language. It means that user need not to write a program to perform a database task like insert, update, delete and retrieve. User just need to provide his request in a structured manner to the system and system automatically take care of his request. It processes request and provide the desired results without need to write a single line of code. In simple words, we just need to provide what is required to be performed. There is no need to provide the details like how to perform the task. System automatically perform the task. Our job is just to provide the request to the system in a structured manner so that system can understand our request. And that's why it is called as structured query language, because we have to write our query in a structured manner or a defined manner so that system can understand our query. Once system understand our query, it automatically provide the output without writing a single line of code. Thus, user need not to write any procedure, algorithm or program to perform basic operations like insert, update, delete or retrieve from the database. He can simply use SQL to perform all those tasks. While in procedural language like C, we have to write a procedure or algorithm to perform any task. For example, if we just want to add two numbers in C programming language, we have to write a program or algorithm for that operation. But in SQL, there is no need to write algorithm or program. You simply need to provide the request in a structured manner to the system and system automatically perform that task. This non-procedural nature of SQL make it very simple and easy to use, and this is the major strength of the SQL, and this is the reason why SQL is so much popular, because we can perform all database operations like insert, update, delete and retrieve without writing programs. SQL statements are broadly classified into three types, and these are data definition language, data manipulation language and data control language. In data definition language, we have three statements, that is create, alter and drop. Create is used to create the schema or tables, alter is used to change the structure of tables and drop is just to drop the structure of table. The data manipulations is performed by data manipulation statements, and these are insert, update, delete and select. Insert is used to insert the data into the database. Update statement is used to make modification in the database. Delete is used to delete the rows or data from the table, while select statement is used to retrieve the data from the database. Data control language is used to perform some transactions. If we want to make our changes permanent into the database, we can use commit command. And to undo those changes, we have rollback command. To assign some privilege or to rights to different user, a database administrator can use grant command. And to roll back those rights or privilege from the user, we can use revoke command. In this course, we will use all these statements one by one to perform different database operations. We will use Oracle to perform all operations in this course. And Oracle has three major data types, that is number, character and date. Number is used to store numeric data like roll number, marks and age, while character is used to store alphanumeric data like name, class and address. Date is used to store fields like date of birth and date of joining. We will use these data types significantly during creation of tables and its manipulation. In order to invoke the SQL, we will use one interface called as iSQL+. Here I stand for interactive, SQL stand for structured query language, plus indicate that Through this interface, you can run both SQL as well as PL/SQL commands. Here PL refer to procedural language. Oracle provide iSQL Plus interface to query the database from internet browser. So from browser, a client can send the request to the server. The query is executed at the server and results are displayed to the client. Now we will demonstrate how we can invoke iSQL Plus. So simply I select that options as a Oracle database server. When you click on it, there is a one options go to database homepage. Select this option. This will open iSQL Plus on a browser. So this browser interface of Oracle here is known as iSQL Plus. It will ask for your credentials like username and password. After logging on it, the first window appear like the task which I want to perform. It has the options of administration, object browser, SQL and utility. So here my task will be to execute SQL statement. So I will select SQL. It will open another page having further three options: SQL commands, SQL script and query builder. Yes, we have to select SQL commands. So when I click on SQL command, another page will open, and this is the page where we can enter our SQL as well as PL/SQL commands, and we can use click run to see the results. So here run is used to execute the statements. So this is iSQL Plus interface which is used to execute SQL and PL/SQL statement. We will use this interface for our further sessions. Thanks for watching this video.
Hi, welcome to this session on performing basic operation on database with SQL. In this session, we will learn how to decide about the structure of table, how to create a basic table in SQL, and we will learn how to perform four basic operations, that is insert, update, delete and retrieve on the database with the help of SQL. We will take case study of student database to perform these operations. We will switch between presentation and SQL interface to demonstrate these concepts. For creation of student table, first step will be to decide about the fields or attributes for which we wish to store the data. Normally, we are interested to store roll number, name, class, marks and date of birth information of student. So for this case study, we will consider these columns. However, you can add more columns depending upon your requirement. It is important to note that blank space is not allowed in column names. Next step will be to decide about data type of columns. In Oracle, we have number, character and date as basic data types. Thus, roll number will be of number data type, name and class will be of character data type, marks will be of number and date of birth will be of date data type. Next step will be to decide about their size. Roll number may be of maximum 8 digits, so let's keep its size as 8. Name may be of maximum 20 characters, so keep its size as 20. Class as 10, marks as 3, and for date of birth there is no need to specify its size, as Oracle automatically define it to accommodate day, month, year and time information. Now we are ready to create student table. To create table, you can use create table statement, and its syntax is create table, table name, and in braces you have to provide column name, its data type and size. Since we have decided about these components of student table, let us create student table by putting name of table, columns, their data type and size at their respective places, and we are ready with its syntax. Now it is a time to create this table at SQL. So for this I will copy this statement and execute it at SQL interface. So this is create table statement. Go to SQL interface, log in on it, select SQL, SQL commands, and here we have to execute SQL statement. Copy this create table statement, press run to execute it. Congratulations, table has been created. To check the structure of this table, we can use describe table name statement. So by using describe student, we can check its structure. By executing this statement, you can check student is the name of table. These are the column names, data type, their size, and constraint information about the table. We will discuss constraints in more detail in next session. Let us insert some record in this table. For this, you can use insert statement, and its syntax is insert into table name, values, value of column 1, value of column 2, and so on. Let us put these values for record 1, and insert statement will look like this. Let us execute this statement to insert a record in SQL. So for this, I will copy this insert statement and execute it in SQL interface. Press the button run to execute it. One row has been inserted. Here, 1 is the roll number, Ram is the name, BE is the class, 100 is marks, and this is his date of birth information. There are some important points we should keep in mind during usage of insert statement. Character and date values should be supplied in single quotes. Default format of date is DD, MON, YY. Sequence of values given in insert statement must match with corresponding columns. Means first value is stored in first column, second value is stored in second column, and so on. Number of supplied value must be equal to the number of columns in the table. SQL statements are case insensitive, but character values which we have provided in single quotes are case sensitive. It means name and class will be stored in the same case in which we have entered these values. Let us insert some more records in this table. Row has been inserted. Let us insert a record for row number 3. It has been inserted. Same operation will be repeated for row number 4 and row number 5. So now we have inserted 5 records in this table. To retrieve or select these records, you can use select statement, and its syntax is select column name from table name, where condition, order by expression. Here where and order by are optional because it is written in square brackets, and its basic syntax is select column name 1, column name 2, and so on from table name. Let us retrieve roll number and name information of all the students. For this, the statement will be select roll number, name from student. Let us execute this statement to check its result. Press the button run to execute it, and here is the list of 5 roll number and their name information. The asterisk sign is used to select all the columns in the table. This is very useful when we don't know the column names or when we are too lazy to type all the column name. It shows all the columns and rows of the table. You can clearly check that character values are stored in the same case and the records have been inserted in the same sequence. Sometimes we wish to list limited number of records
based on some condition. Then we can use where clause. To display the information of B class, we can use select star from student where class equal to BE. Let us execute this statement. It shows desired record. It is important to put name of class in uppercase because BE has been stored in this case for roll number 1. But to show the record for roll number 2, the statement will be class equal to BE in lowercase and it shows this record. So you should be very careful about the case during query the character data. Sometimes it is necessary to arrange records in ascending and descending order on some column. For this, we can use order by clause with column names. We can use select star from student ordered by marks to display the information in ascending order of marks. Here is the output and records has been arranged in ascending order of marks. To arrange the records in descending order of marks, we can use the keyword DESC descending and it will arranged in descending order of marks. Sometime after insertion of data, there is a need to make modifications in data. For this, we have to use update statement and its syntax is update table name, set column name 1 equal to new value and so on. We can also use where clause to limit the operation to specific rows only. To change the marks of roll number 1 to 150, we can use this statement. Let us execute this statement. It shows one record has been updated successfully. We can always use select statement to verify its result. Yes, marks of roll number 1 has been updated to 150. Single update statement can also be used to update multiple columns. Here, this update statement is used to update date of birth and class information of student named Rahat. It is important to keep in mind the case of name. If we write the name in different case, no row will be updated as name has been stored in this way only. Now it is a time to delete some unwanted data from table. For this, we can use delete statement and its syntax is delete from table name where condition. Here from and where are optional. To remove the record of BE student, we can use delete from student where class equal to BE. Let us execute this statement to check its result. So here one row has been deleted and we can use select statement to verify its result. Yes, roll number 1 of BE student has been removed. To delete all the records of this table, we can use delete student and it will remove all the records of this table.
Now let us summarize all the concepts we have learned in this session. In this session, we have performed all 4 basic operations, that is insert, update, delete and retrieve on student database with the help of SQL. We are able to perform these operations in a very quickly and simplified manner. This shows the power of non-procedural nature of SQL. If we have to perform all these operations in procedural language like C, we have to write programs for each operation and it will take a lot of time and procedure will be very complex. But in SQL, we are able to perform all these operations without writing a single line of code. This simplicity of SQL is the major reason for its popularity. Now it is time to practice these commands. All the commands used in this session is available as a script file for your ease. You are further advised to read more on select statement in reading section of week 1. Thanks for watching this video. Hi, welcome to this session on need of constraints and its type. In this session, we will discuss the importance of applying constraints during creation of tables to ensure integrity of data. We have already created a basic table in previous session. In this session, we will discuss the problems of this basic table and then understand the solution of this problem through integrity constraints. Before the start of this session, let us revise the concept we have learned in previous session. As we have learned to create basic student table and had performed all database operations, that is insert, update, delete and retrieve on it. But sadly, the basic student table created in previous session suffered from some anomalies. In order to understand these, let us move to SQL interface. This is the student table we had created in the last session. Let us insert some new record in this table. A record has been inserted. If I execute this statement again, then same record will be inserted again. You can check that there is no restriction on insertion of duplicate values in this table. It is very natural that in a table there must be some column which should be mandatory or compulsory. In case of student table, roll number should be a compulsory column. But here, if I put null, which means missing or unknown value at roll number position and execute this statement, then again this record get inserted and it should not be. Here null or blank has been stored for roll number. Even there is no check on the validity of column values. If I insert BA as a class which is not in my university, then again this record has been inserted. There is no check to ensure validity of its value. Even you can store any random text in this column. You can also store an active value in marks column of this table. We can summarize that in basic table there are issues of duplication and validation of data. To ensure that only correct data is stored in the database, we can apply constraints during creation of table. And in this session we will learn how to apply these constraints on the table. The restrictions or rules to ensure that only correct data is stored in the database are known as integrity rules or constraints. There are two categories of constraints, and these are column level and table level. If a constraint is applied on a single column of a table, for example, roll number is unique and then it is a column level constraint. And if a constraint is applied on more than one column of a table, then it is a table level constraint. For example, in primary schools, where in a class every roll number starts with 1, then combination of roll number and class is unique and it is a table level constraint. There are 6 types of constraints and these are not null, unique, primary key, check, default and foreign key constraint. Now let us summarize the concept we have learned in this session. In this session we understood the importance of constraints on a table. We have discussed its two types, column and table level constraint. We have also discussed different types of constraints like not null, unique, primary key, check, foreign key and default constraint. In next session, we will discuss these constraints in more detail. Thanks for watching this video. Hi, welcome to this session on type of constraints. In this session, we will discuss not null, unique and primary key constraints. Let's start this session. First type of constraint is null or not null constraint. To make a column mandatory or compulsory, we can apply this constraint during creation of table. By default, all columns are optional and they have null constraint. To apply this constraint, the syntax is column name, data type, size, and with this we can specify our constraint not null. Every constraint internally assigned a unique name by Oracle. However, we can give our own unique name to constraint by using keyword constraint name, but it is optional. Let us apply this constraint on student table. Here, roll number is not null. It means null is not allowed in this column and it is a compulsory column. Let us move to SQL interface to demonstrate this concept. Let us create student table with not null constraint. Check, we got error because student has already been exist. So let's first drop this table. Now create a new student table with roll number as not null constraint. Table has been created. To check its effect, let us insert a new record in this table. Now we have a roll number as a compulsory column. I have inserted row for roll number 1. If I make roll number as null and try to insert this value, I got error message that I cannot insert null into roll number. Fine, we have achieved our objective. To enforce uniqueness of the column or group of column, we can apply unique constraint. It removes duplicacy or repetition of data. In syntax, we have to write unique with their column name, data type and size. Optionally, we can specify constraint name. Let us apply this constraint on a student table. Here, roll number has been made unique by applying this constraint. We can also specify our own constraint name during creation of table. Let us demonstrate this concept in SQL. Let us first drop earlier student table. Table has been dropped. Now let us create a new student table with the unique constraint on roll number. Table has been created. Insert a record of roll number 1 in this table. Record has been inserted. If I try to insert same record again in this table, it is not allowed. System raise an error message that unique constraint has been violated. Here, system is the username and sys_this number is the unique name assigned by Oracle to this constraint. If I try to insert 2, it is allowed, but repetency of this value is not allowed. It is important to note that null is allowed in unique constraint and even we can store duplicate null values because null means unknown value and one null is not equal to another null. So that's why in unique constraint you can store duplicate null values in the column. To make roll number and class combination unique, as in case of primary school database, we can use this statement. Here, unique is a table level constraint and it has been applied on roll number and class combination. We can specify table level constraint after specifying all the columns. We can also specify our own unique constraint name to this table level constraint. Let us demonstrate this concept in SQL. Let us create primary_student table where unique constraint has been applied on roll number and class combination. Table has been created. Let us insert some record in this table. I am going to insert record of roll number 1 in first class. It is allowed. If I try to insert roll number 1 in same class, it is not allowed. But roll number 2 is allowed in the same class. Roll number 1 can also exist in second class. Let us check this insertion. Yes, it is allowed. Roll number 2 can also exist in second class. So you can clearly check that here roll number and class combination is unique. If I try to insert same record, it is not allowed. And these are the records which we have inserted. So we have inserted roll number 1 and 2 in first class and roll number 1 and 2 in second class. You can check. Roll number can repeat, class can repeat, but combination of roll number and class is unique. Yes, we have achieved our objective. Up to this point, we have learned the concept of normal and unique constraint. With normal constraint, we can make a column mandatory or compulsory, but then repeated values are allowed in normal constraint. We have unique constraint to enforce uniqueness of a column. But with unique constraint, column is not mandatory. It is still optional. But sometimes we wish to enforce both normal and unique constraint at the same time on a column. And for this, the solution is primary key constraint. Primary key constraint on a column enforces uniqueness and normal at the same time. Let us learn the concept of primary key constraint. Primary key constraint is a combination of both unique and normal constraint. It is used to identify unique row of a table. If primary key is applied on a single column, then it is called simple key, and if it is applied on a combination of column, then it is known as composite key. Its syntax is column, data type, size, and we have to specify primary key. We can also give our own constraint name to this constraint. Let us apply this constraint to student table. Here, roll number is the primary key constraint. Let us execute this statement to demonstrate this concept. Here, I am going to create student table with roll number as a primary key. Table has been created. Let us insert record in this table. Record of roll number 1 has been inserted. If I try to store repeated value, it is not allowed. If I try to store null value in roll number, it is also not allowed. Of course, I can store record for roll number 2. Repeated value is not allowed. Null is not allowed. Yes, I have achieved my objective. To make roll number and class combination as a primary key in primary school database, we can use this statement. Here primary key is a table level constraint and it has been applied on roll number and class combination. Let us demonstrate this concept. I am going to create primary underscore student table with roll number and class combination as its primary key. Let us insert some record in this table. I am going to insert record of roll number 1 in first class. It is allowed. Of course, repeated value is not allowed in the table. If I try to insert null in roll number, it is not allowed. Null is also not allowed in class. I can insert roll number 1 in second class and repeated values are not allowed. It means in primary key both uniqueness and Ordinal constraints are applied at. Now let us summarize the concept we have learned in this session. In this session, we have learned the importance of ordinal, unique, and primary key constraint. We have demonstrated all these concepts through SQL commands. Now it is a time to practice it. All the commands used in this session are available as a script file for your ease. In next sessions, we will discuss check, foreign key, and default constraints. Thanks for watching this video. Hi, welcome to this session on check constraint. In this session, we will discuss importance of check constraint to enforce integrity of data. We will demonstrate its implementation, and in the end, we will discuss its limitations. Let's start this session. To ensure validity of data during insert operation, we can use check constraint. It allows storage of only valid values, and we can specify valid or allowed values as logical expression. If logical expression evaluates true, then value is inserted. Otherwise, system will return an error message. Its syntax is column name, data type, and size. With this, we have to supply check logical expression. You can note that its syntax is different from other constraints. It is optional to specify constraint name during application of this constraint. Let us apply this constraint on a student table. In case of student database, we wish to define BE, ME, and MCA as valid classes, and marks should be greater than or equal to 0. For this, we can use this statement. Let us execute this statement to demonstrate this concept. Let us create student table with check constraint on class and marks. Table has been created. In this case, only BE, ME, and MCA classes are allowed, and marks should be greater than and equal to 0. It is important to note that for check constraint on class, we have specified our own constraint name, while for check constraint on marks, we have not specified our constraint name. For this, constraint name will be assigned by Oracle. Let us insert record in this table. Record for roll number 1 has been inserted. If I try to insert BA for roll number 2, it is not allowed, and system raise an error for violation of check constraint. You can note that check constraint raised by Oracle carries user defined name class underscore check. If I try to insert negative value in marks, it is also not allowed. And in this case, constraint name is assigned by Oracle and it is sys underscore this number. It is also important to note if we try to insert BE in lowercase, it will also not allowed because we have specified BE in uppercase during check constraint. So we should be very careful about the case of character values. In case of library database, we have roll number, book number, date of issue, and date of return as its column. In this case, we wish that date of return should be more than date of issue. For this, we can apply table level constraint by specifying this condition after specifying all the columns. Let us execute this statement to check its result. Let us create library table with table level check constraint that date of return should be more than date of issue. Table has been created. Let us insert this record with 12 Jan 2017 as date of issue and 20 Jan 2017 as date of return. Record has been inserted. But if I make date of return less than date of issue, then system raise an error message and this insertion is not allowed. Yes, we have achieved our objective. There are some limitations of check constraint. As we have applied check constraint on class column to ensure that only BE, ME and MCA classes are allowed in our university, but it suffers from some anomalies. Let's suppose our university has started an MBA course and we wish to insert roll number 4 into this course. But here it is not allowed. In order to make this insertion possible, we have to change the structure of this table by adding MBA into check class list. But for this, we have to make change in the schema of table. But it is not desirable. Its solution is foreign key constraint. So we can summarize that check constraint has its own limitation. It cannot be applied on those columns whose value is going to change in future. It can only be applied on those columns whose value is not going to change in future. For example, it is valid for marks that it should be greater than and equal to 0. So we can apply check constraint for this. We can also apply check constraint for gender field that gender should be male, female and transgender. But it cannot be applied in case of class where classes can be added or removed in the future. Let us summarize the concept we have learned in this session. In this session, we have understood the importance of check constraint and discussed its implementation. We have also highlighted the limitations of check constraint. In next session, we will discuss the concept of foreign key constraint and default constraint. You are further advised to read more on creation of table with constraints in reading section of week 2. Thanks for watching this video. Hi, welcome to this session on concept of foreign key constraint. In this session, we are going to discuss very important concept of relational database management system, that is foreign key constraint. In this session, we will discuss why there is a need of foreign key to enforce integrity of data. We will discuss its syntax and we will highlight different options in the syntax to enforce foreign key constraints. Let's start this session. Let us understand the concept of foreign key constraint through employee department database. For this, we have employee table. Here we have employee number, employee name, job and department number as its column. And I have inserted 5 records. In our university, let's suppose only 3 departments are allowed, and that is 10, 20 and 30. I cannot apply check constraint for this because departments can be added or removed in future. For this, the solution is foreign key. To implement it, I will create a master table named as department with columns department number and department name and insert all valid department numbers into this table. Department number of department table will be made is primary key. To enforce integrity of data, department number of employee table will make as foreign key. It means it will refer department number of department table for its validity. Only those values are allowed in department number column of employee table that exist in department table. Only 10, 20 and 30 is allowed in department number column of employee table. If I try to insert a new employee of 6 and assign it to department number 40, it will be not allowed because corresponding department number is not present in master department table. Department number of employee tables refer to primary key of department table for its validation. That's why department number of employee table is called as foreign key. Thus, foreign key is used to enforce referential integrity of data, and it drives its value based on primary key of some other table. The table to which it refers is known as master or parent table, and the table in which foreign key is present is known as child table. Its syntax is column name, data type, size, references, table name, and column name. Here, references table name is master table, and in braces we have to supply the column name of master table to which it refers. We can also specify on delete restrict, on delete cascade, or on delete set null during creation of foreign key. We will discuss the importance of these in next coming slides. Now let us implement foreign key on employee department database. First step will be to create master department table. For this, department number is primary key. Second step will be to create employee table, and in this department number is foreign key and it refers department table's department number for validation of its value. Let us consider a case where user tried to delete department number 30 record from department table. It should not be allowed because then record of employee number 5 will become invalid. Oracle achieved this through on delete restrict constraint on foreign key, and it is a by default option on foreign key constraint. But what will be the solution if we have to delete department number 30 from department table? Then the solution is on delete cascade constraint, where department number 30 will be removed from both department and employee table at the same time. So if we issue this statement with on delete cascade constraint, then department number 30 will be removed from department as well as employee table. It means if department closes, then corresponding employees will be fired. But sometimes we wish to remove department number records without deleting corresponding employees. Then the solution is on delete set null. In this, corresponding records of employees will not be removed, but their department number will be set to null. Here department number 30 has been removed from department table, but their corresponding employee exists and its department number will set to null. We achieve this through on delete set null constraint. To implement these concepts, we can specify it during creation of foreign key constraint. Here, department is a parent table and employee is a child table. We have applied on delete restrict constraint during creation of foreign key. It means we cannot remove master record or parent records if they have their corresponding child record present in child table. We can also specify on delete cascade to remove both parent and child record at same time. We can specify on delete set null to set null in child table if corresponding parent record has been removed. Now let us summarize the concept we have learned in this session. In this session, we have understood the importance of foreign key constraint. We have discussed its different options like on delete restrict, on delete cascade, and on delete set null to enforce integrity of data. In next session, we will demonstrate its concept. We will also discuss default constraint and different means to access information about constraints applied on a table in coming session. You are further requested to read more on creation of table with constraints in reading section of week 2. Thanks for watching this video. Hi, welcome to this session on demonstration of foreign key constraint. In this session, we will implement foreign key constraint in SQL. We will understand the importance of different options of foreign key constraint like on delete restrict, on delete cascade, and on delete set null by enforcing different type of constraints. Let's start this demonstration. Let us first create master table department with department number as its primary key. Table has been created. Now we will create employee table with employee number as its primary key and department number as its foreign key, which refers department table's department number column for its validation. Table has been created. Now let us insert some record in master table. Record for department number 10 has been inserted. Similarly, we will insert the record for department number 20 and insert the record for department number 30. Three records has been inserted in department table for department number 10, 20 and 30. Now let us insert some records in employee table. I am going to insert record for employee number 1. He belongs to department number 10. It has been inserted. Let us insert some more records. We have inserted 5 records in employee table for department number 10, 20 and 30. If I try to insert this record, system has raised an error for violation of integrity constraint. And here violation is parent key not found. It means that 40 is not present in parent department table. If I change it to 30, it will be allowed. But if I try to store 50, it will not allow because again there is a violation of parent key. So now we have these 3 records in department table and these are the records of employee table. And in employee table we have 6 records. In this 2 records belong to department number 10, 2 employees belong to 20 and 2 belongs to 30. Now what will happen if I try to delete record of department number 30 from master table? It is not allowed because child record has been found for this parent table. So until we remove corresponding child record, deletion in master table is not allowed. So for this, first we need to delete employee tables department number 30 records with the use of this statement. Then only we can remove records from department table. Because here we have created our table with on delete restrict option. This is by default option. To demonstrate on delete cascade option of foreign key, let us create employee table with this option. For this, first we need to drop our previous employee table. Now let us create this employee table with on delete cascade option of foreign key. Table has been created. Now let us insert some record in this table. One record has been inserted. Let us insert some more records. Here I have inserted 5 records in employee table. And these are the records of department table. Now what will happen if I issue this statement to delete record of department number 30 from master department table? Here I have created foreign key on employee table with on delete cascade option. Yes, in this case record of parent table has been removed. And if I check the records of employee table through this statement, then it verifies that the child record corresponding to department number 30 has also been removed from this table. It means when we use onDelete cascade option of foreign key, then corresponding records are removed from both parent as well as child table. Thus, if department closes, then corresponding employees of this department have automatically been fired from the organization. Since this is not always desired, so we have another option, that is onDelete set null with foreign key. To demonstrate this concept, let us first drop previous employee table and create new table. Table has been dropped. Now I am going to create employee table with onDelete set null option. Table has been created. Here I have inserted 5 records in employee table, and these are the records of department table. Now what will happen if I issue this statement to delete record of department number 30 from master department table? I have created foreign key on employee table with onDelete set null option. Let's execute this statement. Yes, in this case record of parent table has been removed, and if I check the record of employee table, it verifies that child record corresponding to department number 30 has not been removed from the database, and null has been inserted in department number column for this employee. It means his corresponding parent department has been removed from the database. In this case, if department closes, then corresponding employee of that department will not be fired, but their corresponding department will be set to null, and later on he can be shifted to other department. Their new department number can be updated with update statement as shown here. Here, all those employees whose department has been closed is shifted to department number 10. We have demonstrated the implementation of various onDelete options of foreign key constraint. Let us implement the concept of foreign key on student database. So we have already learned that we cannot apply check constraint on class column to enforce its integrity. So how we can apply foreign key on class column? For this, we have to create a master table class with column class and class description. And we have inserted all valid classes in this table. Class will act as a primary key of master table class, and class column of student table will act as a foreign key. Only those values are allowed in class column of student table which exist in class field of class table. It means only BE, ME and MCA classes are allowed. How we can add MBA class in this database? Solution is very simple. We have to insert MBA record in class table, and then it is allowed to add MBA in student table. So yes, we can add roll number 6 in MBA class. With this, we have completed the implementation and discussion on foreign key constraint. Now it is a time to practice it. All the commands used in this session are available as a script file for your ease. You are requested to practice it on SQL for mastery of these concepts. Thanks for watching this video. Now let us consider last constraint, default. It is used to assign a default value to a column. It is not actually a constraint. It is important to note that data type of default value should match with the data type of column, and its syntax is column name, data type, size, default value. Let us apply default value to marks column of a student table. Here we have assigned a default value 60 to marks column of student table. Let us implement this concept. This create statement can be used to assign default 60 value to marks field of employee table. Let us execute this statement. Table has been created. To insert a default value in this column, we have to use column specific insert statement. In this insert statement, only 4 columns have been specified and 5th column marks has not been specified. It means we have to specify only 4 values in insert statement in the sequence of roll number, name, class and date of birth. In this case, default value will automatically assigned by Oracle to marks. Let us insert this record. Let us view the content of this table to check the result of insert statement. Default 60 marks has been assigned to roll number. It is important to note that if no default value is assigned for this column, then null will be inserted as a value of marks. To view the detail about constraints, we can use user underscore constraints and user underscore cons underscore columns table. These are the two tables which are maintained internally by Oracle to store the information about constraints. We can query this table through statement like select star from user underscore constraints where table underscore name equal to name of table. It is important to specify the name of table in uppercase because it is internally stored in uppercase. We can query both the tables in the same way. Let us execute these statements to check its results. It is not possible to remember the value of check constraints or the columns on which we have applied the constraints. For this, we have user underscore constraints data dictionary table. This table can be queried to get the details about the constraints imposed on a table. Let us execute this statement to check the detail about constraints imposed on student table. This query shows that there are two constraints applied on student table. Here C refers to check constraint and P refers to primary key constraint. Here is the list of values allowed in the check constraint and this is constraint name. And sys underscore this number is the constraint name for primary key assigned by Oracle. We can also query user underscore cons underscore columns table to get the name of the columns on which these constraints are applied. Here it provides column name and corresponding constraint name. Both of these tables are very useful to know the detail about the constraints. It is important to supply the name of table in uppercase during query these tables. If you supply the name of table in lowercase, it will show no record because table name is stored in uppercase by default. इस सेशन में हमने डिफॉल्ट कंस्ट्रेंट और इसके यूसेज के बारे में समझा। हमने यूजर अंडरस्कोर कंस्ट्रेंट और यूजर अंडरस्कोर कॉन्स अंडरस्कोर कॉलम्स टेबल्स की इंपॉर्टेंस के बारे में भी समझा। हमने ये देखा कि कैसे इन टेबल्स को यूज करके हम कंस्ट्रेंट्स के बारे में इंफॉर्मेशन रिट्रीव कर सकते हैं। इसके बारे में और डिटेल में पढ़ने के लिए आप रीडिंग सेक्शन ऑफ वीक 2 को रेफर कर सकते हैं। इस सेशन में यूज की गई सारी कमांड्स एज ए सीक्वल स्क्रिप्ट आपकी ईज के लिए अवेलेबल हैं। आप इनको डायरेक्टली एग्जीक्यूट करके इन कंसेप्ट्स को इंप्लीमेंट कर सकते हैं। थैंक्स फॉर वॉचिंग दिस वीडियो। Hi, welcome to this session on alteration in table structure. In this session, we will learn how we can change the structure of an existing table with the help of alter statement. In alter statement, we have three options: to add, to modify, and to drop. And in this session, we will discuss add option of alter table. Let's start this session. As we have discussed with alter table statement, we can add one or more columns or constraints to existing table. We can also modify data type or size or integrity constraints on columns through this statement. Alter table can also be used to drop existing columns or constraints. To alter a table, user must have a right or privilege to perform this operation. Syntax of alter table statement is alter table, table name, and it has options to add, modify or drop. We have to use one of these options with alter table. Let us understand the use of this statement. Suppose during creation of table you forget to add some columns to a table. You can add these columns later by using add options of alter table. Its syntax is alter table, table name, add column name, data type and size. We can also specify constraints with this. Let us understand the usage of this statement. Let's add address and mobile number column to existing student table. For this, the statement is alter table, table name, add address, data type and size, and then mobile number, its data type and size. When we execute this statement, two columns, address and mobile number, will be added into existing student table. Suppose you forget to add primary key constraint on roll number column of student table. We can enforce this constraint on existing student table through this statement. It is alter table student, add primary key, and in brackets we have to specify the name of column on which we wish to enforce this constraint. And in this case, it is roll number. Let's apply foreign key constraint on class column of student table so that it refer to class detail table's class column for its validation. Its statement is alter table student, add foreign key, column name is class, references the name of parent table, it is class underscore detail, and the column to which it refers, and in this case it is class. Let us execute these statements to demonstrate these concepts. Here we already have a student table with 4 columns: roll number, name, class and marks, and these are its content. It has only one row. Now let us add some more columns into this table. For this, the statement is alter table with add options, and here we are going to add address and mobile number columns into this table. If I execute this statement, I got a message table altered. And if I check its structure through describe table name statement, it shows that now it has 6 columns and address and mobile number has been added into this existing table. If I query this table, it shows that for existing roll number, address and mobile number is null. In order to assign some value to address and mobile number for roll number 1, I have to use update statement. This update statement is used to set address as Thapar University Patiala, phone number as this number for roll number 1. Let us execute this statement. So one row has been updated. If I check the content of student table, it shows that address and mobile number has been added for roll number 1. So in this way, with add option of alter table statement, we can add columns to existing table, and we can use update statement to add some values to those columns. Now let us add primary key constraint to roll number column of student table. Table has been altered, and describe student statement shows that roll number is now the primary key. Now let us add foreign key constraint to class column of student table, and it will refer class underscore detail parent table's class column for its validation. After executing this statement, I got error message table or view does not exist. It means that master table class underscore detail has not been created. To add foreign key constraint, it is important to first create master table to which it refers. So let us first create master table. This create table statement is used to create class underscore detail master table with class its primary key. Table has been created. Let us insert some record in this table. One row has been inserted. Now let us enforce foreign key constraint on student table through this statement. Table has been altered. This is all about the demonstration of alter table statement to add columns or constraints to an existing table. Let us summarize the concept we have learned in this session. In this session, we have learned the concept of add option of alter table statement to add column or constraints to an existing table. We have also demonstrated its use in SQL. In next session, we will discuss modify and drop option of alter table statement. Thanks for watching this video. Hi, welcome to this session on alteration in table structure. In this session, we will discuss modify and drop option of alter table statement. Let us revise the content we have learned in our previous session. In previous session on alter table statement, we have discussed the need of altering the structure of table. We have also discussed add option of alter table statement to add column or constraints to an existing table. We have also demonstrated the usage of this in SQL. In this session, we will discuss the modify option of alter table statement to change data type or size of existing columns of the table. We will also discuss drop option of alter table statement to drop existing column or constraints from the table. Let's start this session. Let us demonstrate these statements. Here we have a student table with 6 columns and these are their data types. These are the contents of student table. It has only one row. Now if we have to change the size of name field from character 15 to character 20, the statement will be alter table student modify name character 20. If I execute this statement, it shows table has been altered and describe student indicate that it has been changed. Now let us change the data type of existing name column. Here it is character and I can change it to another compatible data type, that is variable character. In order to change the data type of name column from character to variable character, I can use this statement. Table has been altered. Describe table statement shows that name has been changed from character to variable character. Here the data type of address is variable character and its size is 50. Let us reduce its size from 50 to 20. This alter statement is used to reduce the size of address from character 50 to character 20. If I execute this statement, table has been altered. But if I try to reduce it to 10, then it is not allowed. It means I can only reduce the size of variable character column up to a point to which it satisfies the values of existing columns. Otherwise, we have to first delete existing record, then only I can reduce its size. If I try to reduce the size of mobile number column from 10 to 2, it will again not allowed because there is one record which has a mobile number of 10 digits. So in order to facilitate this, I have to delete existing records. Then only I can reduce its size. There are some important points which we should keep in mind while using modify option. To reduce the size of number column, it is mandatory to empty the column for all rows. Reducing the length is allowed for variable character or character column if reduced size satisfy existing values. Otherwise, we have to delete its values for all the rows. Changing the data type of a column is allowed from character to variable character and vice versa. Otherwise, we have to empty the column values for all rows. Sometimes after enforcing a constraint during creation of table, we realize that this constraint is not required, or there are some columns in a table that are not currently applicable, and you wish to drop these constraints or column from the existing table. For this, the solution is drop options of alter table statement. Let us understand the usage of drop option of alter table. To remove primary key constraints from student table, we can issue the statement alter table student drop primary key. And to drop mobile number column from student table, we can issue the statement alter table student drop column name of the column, and in this case it is mobile underscore number. To remove check constraint on marks column of student table, we have to specify constraint name in alter table, and its syntax is alter table table name drop constraint name. But normally we don't know this constraint name, as if we have not supplied it during creation of table, then it had been assigned by Oracle. To know the constraint name, the solution is to query user underscore constraint table. So we can query user underscore table through this statement. This alter table statement is used to drop primary key constraint from student table. It has been dropped. Yes, it has been dropped from roll number column. This statement is used to drop mobile number column from student table. It has been, and we can verify it through described statement. Let us summarize the concept we have learned in this session. In this session, we have learned modify and drop option of alter table statement. We have also demonstrated these statements in SQL. You can further read more on alter table statement in reading section of week 3. Thanks for watching this video. Now let us revise the concept we have learned in this session. In this session, we have learned the usage of Now let us revise the concept we have learned in this session. In this session, we have learned the usage of in this session. Now let us revise the concept we have learned in this session. In this session, we have learned the usage of drop and modify op. Now let us revise the concept Now let us summarize the concept we have learned in this session. In this session we have learned drop. In this session we have learned modify and drop option of alter table statement, and we have demonstrated its usage. Let us summarize the concept we have learned in this session. In this session, let us summarize the concept we have learned in this session. In this session, we have learned the concept of modify and drop option of alter table statement. We have also demonstrated the usage of these statements. You can further read on alter table statement in reading section of week 3. You can further read on alter table statement in reading section of week 3. You can further read on alter table statement in reading section of week 3. Thanks for watching this video. And we can verify it through describe statement. To drop check constraint on class column, we have to supply constraint name, and we don't know its constraint name. To drop check constraint on class column, we have to supply its constraint name, and normally we don't know it. To retrieve the information about constraints, we can issue this statement. This query Welcome to this video tutorial on joining of table. In this session we will discuss need of join operation and different type of joins. Sometimes it is important to extract data from more than one table, and to extract data from more than one table we have join operation. In SQL we can join multiple tables on the basis of common columns among those tables.
Understand the concept of join with two tables. The first table is employee with columns e-number, e-name, job and department number, while second department table has column department number and d-name. Department number column of department table will act as its primary key, while department number column of employee table will act as its foreign key. And only those values are allowed in department number column of employee table which exist in corresponding master table. Let us retrieve ename and dname column from employee and department table. Here ename is present in employee table while dname is present in department table. We have to retrieve information from two tables, and to retrieve the information we have select statement. So here we have to select ename and dname from two tables. So the corresponding select statement will be select ename, dname from employee, department. If I execute this statement, Oracle internally perform Cartesian product. It means that first record of employee table will make the pair with first record of department number, then it will make the pair with second record and then with third record. It means that first record will make three pairs. Similarly, second record of employee table will also make three pairs with all the records of department table. Same for third record. Similarly, fourth record will make three pairs and fifth record will also make its three pair. It means that five record from employee table will make pair with three record of department table, and there will be 15 records in the output. So here the output will be all possible combination of ename and dname, and this is the concept of Cartesian product. The syntax of Cartesian product is select column 1, column 2, column 3 and so on from table 1, table 2. Here the result will be the Cartesian product of all the rows of joint table. It is important to note that Cartesian product does not require the tables to have common columns between them. And if same column appears in more than one table, then column name must be prefixed with table name to resolve its ambiguity. To retrieve ename and their corresponding dname of all the employees, we have used Cartesian product and its output is 15 record. But of course, this is not the desired output. Actually, we require only 5 records as the desired output, but it has 10 extra undesirable records. For example, in case of Ram, his department should be computer and it should not be chemical or mechanical. Similarly, in case of Rajesh, his department is chemical but it is not computer or mechanical. In case of Suresh, his department is computer but it is not chemical or mechanical. In case of Ramesh, his department is chemical, and in case of Surinder, his department is mechanical. So here we have to select these desired 5 records from set of 15 records. To select desired records from set of records, we have to use where clause of select statement. As we have discussed in the Cartesian product, first record of employee table make pair with all possible records of department table. Here record of employee who belongs to department number 10 make 3 pairs with department number 10, 20 and 30 of department number. But we are only interested in selection of first pair, while there is a need to discard second and third pair. So it is very natural that only that pair need to be selected where department number of employee table is equal to the department number of department table. Similarly, in case of second employee, we are again interested in those records where their department numbers are equal, and we need to discard those employees where their department numbers are not equal.
So it is very natural to enforce this condition that only select those pair where department number of employee table is equal to department number of department table. In this way, Ram will make a pair with computer department, Rajesh will make pair with chemical, Suresh with computer, Ramesh with chemical, and Surinder with mechanical. And in this way, we will able to select 5 desired record. So let us write the corresponding select statement. So the select statement will be select ename, comma dname from employee, comma department, where employee dot department number equal to department dot department number. Since department number is common in both the tables, so it is important to add table name as a prefix to column name to resolve its ambiguity. This is the concept of inner join. So if we add where condition to Cartesian join, then it is called as inner join. So inner join is the most common type of join, and it is a case of Cartesian product that has a where clause. Up to this point, we have discussed two types of join. One is Cartesian product, another is inner join. Inner join has further two types. One is equijoin and another is non-equijoin. Let us understand this concept. If where condition of inner join is based on equality operator, then this is called as equijoin. And its syntax is: a non-equijoin is a case of inner join where condition is not based on equality. In this case, it is based on less than, greater than, or not equal to type of operators. So this is the example of non-equijoin, and here we are using non-equality operator. Example which we have discussed earlier is a case of equi-inner join, because here where condition is based on equality operator.
Let's execute these commands to understand the implementation of join. Here we have employee table with 4 columns: e-number, e-name, job and department number, and there are 5 records in this table. In department table, we have 2 columns, department number and dname, with 3 records, one for computer, another for chemical, and third for mechanical. Now let us write a query to find ename and dname from employee, department. As we have already discussed, it will perform Cartesian product. There are 5 records in employee table and 3 records in department table, and it will make all possible pair and produce 15 records in the output as shown here. But of course, this is not the desired output to display ename and dname for each employee. In order to display ename and dname for each employee, we have to add where clause with Cartesian product as shown here. Here we have added where clause to display only those records where employee's department number is equal to department table's department number. When we execute this query, it returns only 5 rows to indicate ename and their corresponding dname. This is the concept of equi-inner join.
Let's summarize the concepts which we have learned in this session. In this session, we have learned the concept of Cartesian product and inner join. We have discussed two types of inner join. One is equi-inner join and another is non-equi-inner join. In next session, we will discuss outer join and its two types, that is left outer join and right outer join, and self join. Thanks for watching this video. Hi, welcome to this video tutorial on outer join. In this session, we will learn the need of outer join and different types of outer join. Let's start this session. In previous session, we have retrieved ename and dname from employee and department table with the use of equijoin. We have joined both the tables on their common column department number with the use of select statement. And the statement is select ename, dname from employee, department, where employee.department number is equal to department.department number. Here we join both the tables on their common column department number, and to remove the ambiguity in column name, we prefixed table name with this. This query produces these 5 desired records and the concept is equi-inner join. Now let us consider a case where we have added another record in department table for department number 40 with dname civil, and we are interested in retrieval of ename and dname for each employee. To produce this desired output, we are using following select statement, and it is based on inner join. What will be the output of this query? Of course, it will be same and it will produce same 5 records. Because department number 40 in department table is not participating in any pair corresponding to employee table records, so it will not appear in the output. So the output will be same. But it is desirable to produce this output where it is indicated that dname civil has no corresponding employee. So this is more useful output as compared to previous output where we are only showing 5 records. So in order to show this output, what is the solution? So the solution is outer join. In this case, we are interested in displaying all the records of department table in the output, whether its department number column values make pair with department number column values of employee table or not. While in case of equi-inner join, only those records appear in the final output that make pairs. So in equi-inner join, only the records of department number 10, 20 and 30, that is computer, chemical and mechanical departments, will appear in the output. But in order to show record of civil department in the output, we have to display full department table. That's why there is a need to use outer join. Since null will appear in ename column of employee table, we have to add plus sign in where condition towards employee table as shown in this statement. Here plus has been added towards employee table in the equality condition. The plus sign can appear on any side of equality condition, but it cannot appear on the both sides at the same time. As it is shown in the syntax, if plus sign appear on the left hand side of equality operator, then full table will be on right side, so it is called as right outer join. And if plus sign appear on right side of equality condition and full table is on left hand side, then it is called as left outer join. In simple words, if full table appear on left hand side of equality condition, then it is called as left outer join. And if full table appear on right hand side of the equality condition, then it is called as right outer join. It is important to note that it is always opposite to the position of the plus sign. If plus sign appear on right side, then it is left outer join. If plus sign appear on left side, then it is right outer join. So the type of outer join is decided on the basis of position of the full table. The given case to display ename and dname for all the employees by also including those departments having no corresponding employee is a case of right outer join.
Let us execute these statements to demonstrate this concept. Here we have employee table with e-number, e-name, job and department number columns, and there are 5 records in this table for department number 10, 20 and 30. In department table, we have 2 columns, department number and dname, and there are 4 departments in this table, 10, 20, 30 and 40. It is important to note that there is no record in department number 40 in employee table. Let us write a query to find ename and dname for each employee, and for this we are using inner join. If I execute this query, it produces 5 rows and it does not produce any record for civil department. Since civil department exists in this database and there is no employee corresponding to this department, it is important to show this department. In order to display civil in the output, we have to use outer join. And in this case, we need to add plus sign on employee table side. If I execute this, it will produce 6 record as shown here, and now civil department has been added into the output with corresponding employee as null. This output is more useful as compared to the output of inner join. This explains the importance of outer join.
Let's summarize the concept we have learned in this session. In this session we have learned outer join. Its two types, that is left and right outer join. In next session we will learn self join. You can read more on joining of tables in reading section of week 3. Thanks for watching this video. Hi, welcome to this video tutorial on self-join. In this session, we will discuss the need of self-join and its implementation. Let's start this session.
Let us consider employee table having columns employee number, e-name, job, manager number and department number. And we are interested in the retrieval of employee name and their corresponding manager name. Here employee number 1 having name Raj has manager number 4 and his manager name is Ramesh. So thus the desired output pair is Raj and Ramesh. For employee number 2 whose name is Ram has manager number 3 and his name is Rajesh. Thus desired output pair is Ram and Rajesh. Employee number 3 has a name Rajesh and his manager number is 4 whose name is Ramesh. Thus, desired output pair is Rajesh and Ramesh. Since employee number 4, Ramesh, has no manager, so his record will not appear in the output. Employee number 5 has a manager number 4, whose name is Ramesh, thus desired output is Rahat and Ramesh. From the logic of production of desired output, it is clear that here employee number column of employee table is making pair with manager number column of the same table. In this case, column of the same table are making the pair with each other. So this is a case of self-join. To explain the syntax of self-join, let us simplify this employee table by ignoring department number, as it is not playing any role in this process. To perform self-join, let us create a logical copy of employee table named as M. Here we have two copies of employee, first with alias E and second as alias M. Here first record of E having manager number 4 will make pair with employee number column of M having same value, so that employee Raj will have pair with his manager Ramesh. Second record Ram having manager number 3 again will make pair with his corresponding manager Rajesh. Third record Rajesh of employee table will make pair with his manager Ramesh. Similarly, fifth record will make pair with his corresponding manager. Thus the output of this process is for desired record. Let us now write the corresponding query to produce this output. And its statement is select e-name from first table, comma select e-name from second table, where first table manager number is equal to second table's employee number. Here first table employee is aliased as E while second table employee is aliased as M. Since same e-name column has been selected from both the table, to resolve its ambiguity, its table name has been prefixed. So the query is select e.ename, comma m.ename from employee, one alias is E, another alias is M, and e.manager number is combined with m.employee number. It is important to note that here in output we are showing employee underscore name. So first column is aliased as employee underscore name, while second column is aliased as manager underscore name. Now let us produce this output where it shows that there is no manager for employee name Ramesh. In order to include this record in the output who has no corresponding manager, we have to use the concept of outer join. And its query will be, here full table E need to be produced in the output while null appears in the manager name column of M table. So plus will appear towards M. Since full table is E and it appeared on left hand side of equality operator, so this is an example of left outer join. Let us consider employee date of joining table
where we have introduced another column, date of joining, and we are interested in retrieval of employee name who joined their company before their manager. In order to produce this output, first task will be to join employee with their corresponding managers and then check their date of joining with each other. Let us first join employee with their manager with the use of self-join. Here we have created two copies of employee date of joining. One is E and another is M. And we have paired each employee with their corresponding manager by enforcing a joining condition where manager number of first table is equal to E number of second table. Since the date of joining of Ram is less than the date of joining of his manager Rajesh, so Ram will appear as the output. And the query for this output is select E name from employee E and employee M, where E dot manager number is equal to M dot employee number and employee date of joining is less than manager's date of joining. Let's execute these statements to demonstrate this concept. Here we have employee manager table. This is a basic employee table, but we have added another column MGR number in this table to indicate manager number corresponding to employee. Here employee 1 is working under manager 4 and whose name is Ramesh. Employee number 2 is working under manager 3 whose name is Rajesh. Similarly, Rajesh is working under Ramesh and Rahat is also working under Ramesh. And Ramesh is at the top of management and he has no corresponding manager number. Our task in this case is to find out E name and their corresponding manager name. In order to display E name and corresponding manager name, we have to use self-join as shown here. Here we are performing self-join on employee manager table by creating two aliases of the same table. One is named as E and another as M. We are selecting employee name from first alias while manager name from second alias. And we are using join condition that manager number of employee is equal to employee number of manager. Let's execute this query. It shows 4 records in the output to indicate employee name and their corresponding manager name. It does not include the record of employee who has no corresponding manager. In order to include the record of employee who has no corresponding manager, we have to use outer join, and in this case null need to be added on manager side. Let's add plus on manager side. When we execute this query, it shows that Ramesh has no corresponding manager and this output is better as compared to previous output. This indicates the importance of outer join with self join. Let us consider another employee date of joining table where we have added date of joining and manager number with E number, E name and job. And we are interested in finding the record of those employees who joined the company before their manager. In order to perform this task, the first step will be to perform self-join and then select only those records where employee's date of joining is less than employee's date of joining. Let's apply self-join on this table. Here we are performing self-join on employee DOJ table by creating two copies. One is named as E and another as M. We are selecting employee name from E while manager name from M, and we are making a pair on employee's manager number with manager's employee number. This will make self-join and it shows the pair of employees with their corresponding manager. But here we are interested in finding those employees who joined the company before their manager. So there is a need to add one more condition with this self-join, and the condition is employee date of joining is less than manager's date of joining. Let's execute this query. It shows that Ram, whose manager name is Rajesh, joined the company before his manager. If we are only interested in E name, then we can remove manager name, and it shows Ram is an employee who joined the company before his manager. Let's check the validity of this output. From the dataset, it is clear that Ram joined the company in 2004 while his manager joined the company in 2005.
So Ram is the only employee who joined the company before his manager. This shows the importance of self-join.
Let's summarize the concept we have learned in this session. In this session, we have learned about self-join, its working, and its demonstration. With this, we have completed all type of join, which include Cartesian product, inner join, its type, equi and non-equi join, outer join, and its type, left and right outer join, and self-join. You are further requested to read more on joining of tables in reading section of week 3. Thanks for watching this video. Hi, welcome to this session on grouping of data. In this session, we will discuss the need for grouping of data. We will discuss how we can perform grouping of data with group by clause of select statement. We will also demonstrate the use of group by clause statements in SQL. Let's start this session.
It is important to first understand the need of grouping of data. Grouping of data is used to perform aggregate function on a group instead of whole data. For example, to find total number of students in each class, we have to apply total function on a group of class, not on the whole data set. Similarly, to find out total number of boys and girl students, we have to apply total functions for each gender group, not on the whole data set. To find total number of students from each city, we have to apply again total function on each group of city records, not on the whole data set. To find maximum marks scored by boys and girl students respectively, we have to apply maximum functions for each group of gender. So in all these cases, we have to apply aggregate function on each group of data instead of all the records of the table. And to perform grouping of data, group by clause of select statement is used. It is used to make a group on a particular column or group of columns. It divides the rows in a table into smaller groups. The syntax of group by clause is select column, group function, from table, optional where clause, optional group by, and optional order by. It is important to note that in group by, we can supply group by expression to make a grouping on a particular column. We can also use where clause and order by clause with group by clause. To understand the working of group by operation, let us take an example of employee database where we wish to find the total salary of employees for each department. Then in order to find total salary for each department, first task will be to make a group on department number column, and then some function will be applied on the salary field to find the total salary of each department. And in SQL, we have to use group by clause on department number column to make a grouping on this field. And then some function is applied on salary field to display total salary for each department. To illustrate this concept, let's find total salary paid to employees for each department for employee database. Here we have 5 columns with employee number, e-name, job, salary and department number. And we have 9 records in this database. There are 3 records for department number 10, 3 records for department number 20, and there are 3 records for department number 30. To display total salary for each department, salary and department number column play important roles. So let us simplify this data by selecting these 2 columns. Then grouping will be performed on department number column and 3 groups will be created, one for department number 10, another for department number 20 and third group for department number 30.
Then some function will be applied on each group to find total salary for each department as shown here. The query to display total salary paid to employees for each department is select sum salary, comma department number, from employee, group by department number. Here we have aliased sum salary function to total salary. So in the output, total salary and department number will be displayed. And we have used group by clause to make a grouping on department number column. To further understand the role of other constructs of select statement in a group by clause, let us consider second task to display total salary paid to employees for each department number excluding job title professor. So in this case, first step will be to exclude the undesirable records before making the group. And in this case, we have to exclude those records where job is equal to professor. Then after excluding these records, group function is applied on department number to find total salary paid to that group. So in this case, department number and salary column will play a vital role. So let's select these two columns. Here again three groups will be formed, one for department number 10 which contain 2 records, for department number 20 which contain 3 records, and third group for department number 30 which contain 2 records. Then sum salary function will be applied to display total salary for each group as shown here. The query to perform this operation is select sum salary, comma department number from employee, where job is not equal to professor, group by department number. Here we have used where clause to discard job title professor before making the group on department number. In this example, we have shown the usage of where clause with group by clause. Here task 3 has further been extended to arrange the output in ascending order of total salary. And to perform this, we have to use order by clause. So here order by total salary has been added in existing select statement to arrange the record in ascending order of total salary. Let us consider another task 4 where we have to find average salary paid to employees for each department number excluding professors. So then in the same way, first task will be to exclude the record of professors. Then grouping will be made on each department number. Then after making the grouping, instead of finding total salary, we have to find out average salary. So then average function will be applied on each group as shown here. The query will be select average salary, comma department number from employee, where job is not equal to professors, and group by department number. Let us perform the next task to find out total number of employees in each department. Here we have to first make a group on each department number as shown here. Then count function will be applied on each group to find out total number of employees. The query to perform this task will be select count, comma department number from employee, group by department number. In task number 6, we have to find out total number of employees in each job. In this case, there is a need to make group on the basis of job field. To illustrate its working, let's arrange the records in ascending order of job as shown here. Then grouping will be made on each job. For example, a group will be made for job assistant professor, another group will be made for job associate professor, and third group will be made for job professor. Then count function will be applied on each such group to find out the total number of records in each group. You can clearly check there are 4 employees working in assistant professor, 3 employees are associate professor, and 2 are professor. And the query to perform this task is select count, comma job from employee, group by job. So in this session, we have learned about the usage of group by clause, where clause, and order by clause of select statements. Let's execute this statement to demonstrate this concept.
Here we have employee table with 9 records, column E number, name, job, salary and department number. We have 3 records in each department number 10, 20 and 30, and we also have job titles as professors, assistant professor and associate professor. Now let's apply some grouping operations on this database. In order to find total salary paid to employees in each department, we have to make grouping on department number. If I execute this query, it will show the total salary paid to employees in each department number 10, 20 and 30. We can arrange the output in ascending and descending order with the use of order by clause. So here by adding order by department number, I can arrange the record in ascending order of department number. We can also exclude some of the records before making the group. Here we are excluding the records of job title professors before making the grouping on department number. And if I execute this query, it will show the total salary in each department excluding job title professor. To find total number of employees working in each department, we can use count function with group by on department number. If I execute this query, it shows that there are 3 employees in department number 10, 20 and 30. We can also find total number of employees working in each job by making grouping on job title. It shows that there are 4 assistant professor, 3 associate professor and 2 professors in this database. It shows the concept of grouping of data.
Now let's summarize the concept we have learned in this session. In this session, we have learned about the need of group by statement. We have discussed the syntax of group by clause, where clause and order by clause of select statement. In next session, we will discuss the need for grouping on more than one column, and we will also discuss some common errors performed by users during the usage of group by clause. Thanks for watching this video. Hi, welcome to this video tutorial on grouping on more than one column. In this session, we will learn the need to perform grouping on more than one column. We will also learn how we can perform this operation with group by clause of select statement. We will also discuss some commonly performed error by users during the usage of group by clause so that we can avoid it. And in the end, we will demonstrate the implementation of grouping on more than one column. Let's start this session.
Sometimes there is a need to perform grouping on more than one column. It means that first grouping is performed on first column and then within that group, grouping is performed on second column. Let's understand this concept with an example where we wish to find total salary paid to each job title in each department. In this case, first grouping will be made on department field, and then within the group of each department, grouping is performed on job field so that total salary can be found for this subgroup, that is each job within each department. In simple words, here we wish to perform a group within another group. To understand this concept, let us consider the given database of employee having 5 columns: employee number, e-name, job, salary and department number. And we wish to find total salary paid to each job in each department. To perform this operation, only 3 columns, that is job, salary and department number, will play its role. So let's simplify this database by selecting only these 3 columns. To perform this query, first grouping will be performed on department number. First group will be created for department number 10, second for department number 20, and third group for department number 30 employees. Within each group, grouping is performed on job. Since there is only one job title in department number 10,
So subgroup of only one record will be created for job assistant professor, for associate professor, and for professor. In department number 20, we have two records for assistant professors. So these two records will make a one subgroup for department number 20. There is only one record of associate professor in department number 20, so it will make another subgroup. In department number 30, subgroup of assistant professor will have only one record. Same for associate professor, but a professor subgroup will have two records. So here we have a group within another group. First we perform the grouping on department number, and then within each department number we perform subgroups on job title. After creating these subgroups, a sum salary function will be applied to each subgroup to display its corresponding total salary, as shown here. The query to perform above task is select department number, comma job, sum salary from employee, group by department number, comma job. Here in group by clause we have specified two columns, department number and job. It means that first grouping is performed on department number, and then within each department number grouping is performed on job field. Let us consider next task to display total salary for each job in each department, excluding the records of associate professor. In this case, first step will be to exclude the records of associate professors as shown in this database. And for this, we have to use where clause of select statement. After exclusion of these records, grouping will be performed on department number field, and then within each department number, grouping is performed on job field as performed in previous case. Here for simplicity, we are only considering three fields: department number, job and salary. So first grouping will be created for department number 10, then for department number 20 and for department number 30. Here we have two records in department number 10, 2 in 20 and 3 in department number 30. Within each department number, subgrouping will be created on job. We have only one job of assistant professor in department number 10, so this subgroup will contain only one record. Subgroup of professor in department number 10 will also contain one record, while subgroup of assistant professor in department number 20 will contain two records as shown here. Subgroup of assistant professor in department number 30 will contain only one record, while subgroup of professor in department number 30 will have two records. After having each subgroup, sum salary function will be applied on subgroups as shown here. And the query to perform this task will be select department number, comma job, comma sum of salary from employee, where job is not equal to associate professor, group by department number, comma job. Here where clause has been added to remove undesirable records before group by, and in this case grouping is performed on two columns, first on department number and then within each department number grouping is performed on job field. There are some errors which normally a user make in the usage of group by clause, and one should be very clear about this logic so that we should not make such mistakes in the usage of group by clause. In a select statement which contain group by clause, only those columns are allowed in retrieval list of column on which grouping has been performed. No other column is allowed in select column list except group by column. For example, if we are making a grouping on department number field, then we can only retrieve department number column in select column list with some aggregate function as shown here. For example, if we try to select ename with department number column and aggregate function, then it is not allowed because data is already grouped on department number and all the columns of department number are reduced to a single record. And with this single record of department number, we cannot display the group of enames because it will be non-relational as shown here. So it is not allowed.
Is this query is allowed in SQL or not? Yes, it is correct since we are selecting only those columns in the select list which are used in group by. Here grouping is performed on department number and job, and we are only selecting those columns which are used in group by clause. So it is allowed. But if we try to select employee number and job by having a grouping on department number and job, it will be not allowed because employee number is a column on which grouping is not performed. Let's answer this question. Is this query is allowed or not?
This query is not allowed as we are selecting an aggregate function and a column without using a group by clause. Let us move to SQL interface to demonstrate these concepts. Let us again consider employee database with 5 columns: employee number, name, job, salary and department number, having 10 records. Here it has 3 records of department number 10, 3 of department number 20 and 4 records in department number 30. In each department number there are different job titles: assistant professor, associate professor and professor. And in this case we are interested in making the grouping on more than one column. Let us demonstrate this concept. Let's find total number of employees working in each job within each department, and for this we have to make grouping on department number and job columns. It means first grouping will be performed on department number, and within that department number grouping is performed on job title. If I execute this query, it shows 3 columns: department number, job and count in the output. To make this output more informative, let's arrange the record in ascending order of department number. It shows that in department number 10 we have 1 employee working in each job title. In department number 20 we have 1 associate professor and 2 assistant professor. While in department number 30 we have 1 associate, 1 assistant and 2 professors. And this shows the importance of making grouping within the grouping. Here first grouping is performed on department number, and within that field grouping is performed on job title. We can exclude some job titles in this output by using where clause. Here we are excluding the record of associate professors in this output. It shows all the job title except associate professor. There are some common errors which are made by users in the usage of group by clause. Let's understand those errors so that we can avoid that in future. Here we are making a grouping on department number, and we are selecting department number and count of employees in these department numbers. Here we have 3 department and this is the count. In this query we are selecting only department number and aggregate function count. If I try to select any other column in this select statement, it will be not allowed because only those columns are allowed in select statement which are involved in group by expression. Here we are making a grouping on department number, so only department number and aggregate column is allowed. No other column like e-name, e-number is allowed in this query, and if you try to write it, system will display an error message. In order to display department number and job information and total employees in each job, we have to make grouping on job column also. Here we are making grouping on department number and job, and then we are selecting department number, job and aggregate function. This query is allowed because we are selecting 2 columns and both these columns are involved in group by expression. But if I remove job from this, then system will raise an error. So it is important to note that in select statement only those columns are allowed with aggregate functions which are involved in group by expression. It is important to note that if we want to use aggregate function, then it should involve group by expression in the query. If we remove this group by expression, system will raise an error that it is not a group function. So either I have to select only department number, it will execute. But if I want to display count with this department number, then it is important to make a grouping on this column. Otherwise, system will raise an error. This is all about the demonstration of these concepts. Now let us summarize the concept we have learned in this session. In this session, we have learned the need of making the grouping on more than one column. We have also discussed its syntax and its usage. We have demonstrated the use of different examples in SQL to explain this concept. We have also discussed the commonly performed errors by users during the usage of group by clause. In next session, we will discuss the role of having clause of select statement with group by clause. Thanks for watching this video. Hi, welcome to this video tutorial on selection of groups with having clause. In this session, we will discuss the need of having clause of select statement. We will discuss its usage and implementation. Let's start this session. As we have already discussed in previous session, we can use group by clause to make grouping on a single column or group of columns. Sometimes it is important to select some desired group out of all available groups based on some condition. And to perform this task, we have to use having clause with group by clause of select statement. It is important to note that where clause of select statement is used to select desired record, while having clause is used to select desired groups. Let's understand this operation with the help of employee database. Here we have to find total salary paid to employees for each department. As we know, in this operation, salary and department number column will play important role. Let's simplify this data by selecting only these two columns. So first step will be to make a grouping on department number column. Here three groups will be formed, one for department number 10, another for department number 20, and third for department number 30. Then after creating these three groups, sum salary function will be applied to each group to find total salary corresponding to each department. And the query to perform this operation is select sum salary, comma department number from employee group by department number. Now let us extend this operation to display total salary paid to employees in the department and department number only if for those departments where total salary paid in the department is greater than 1,60,000. In this case, after making the groups, we have to select only those groups of department number where total salary is more than 1,60,000. It means we have to discard this group. And in order to discard this group, we have to use having clause of select statement as shown here. So the final syntax to display desired output will be select sum salary, comma department number from employee group by department number having sum salary greater than 1,16,000. It only shows those department number which have total salary more than this value. The final syntax of select statement is select column, comma group functions from table name, optional where clause, optional group by clause, optional having clause, and option order by clause. This is the full syntax of select statement. From now onward, if someone asks you about the syntax of select statement, then you should tell him that its syntax is select column name from table name with optional where clause which is used to select desired records, then optional group by clause which is used to make grouping on one or more than one column, then optional having clause which is used to select desired groups based on some conditions, and then finally optional order by clause can be used to arrange the records in ascending or descending order based on some column. So instead of just stating the syntax of select as select star from table name, you should able to highlight the role of each construct of select statement during discussion. The order of execution of select statement having clause is first grouping is performed, then group function is applied. After making the groups, groups are selected based on the conditions specified in the having clause. It is important to note that having clause can precede group by clause but it is recommended to place it after group by clause because it is more logical. Let us perform this task to display department number where we pay more than 1 lakh as total salary to employees in a single department, excluding job title professor. Also display the output in descending order for their department number. This operation will be performed on the same employee database with 5 columns: e-number, e-name, job, salary and department number. In this case, the first step will be to exclude the undesirable record of professor before making the groups. So these are the records which we need to discard. And in order to select desired record out of this database, we have to use where clause. After selecting these desired records, grouping will be performed on department number field. So 3 group will be formed for each department number 10, 20 and 30, and total salary will be found for each group. The query to perform task up to this will be select sum salary, department number from employee where job is not equal to professor, group by department number. But here we have to select only those groups where total salary is more than 1 lakh. So we have to discard this group. In order to discard this group, we have to use having clause. Then finally, we have to arrange the record in descending order of their department number. And to perform this operation, order by clause has been added to arrange the record in descending order based on their department number. So this is the query to perform this operation. Let us consider some more examples with group by and having. The task is find average salary for each job only if more than 2 employees are working in that job. In this case, we have to make grouping on job. Then we need to find average salary. But average salary will only be calculated if there are more than 2 employees working in that group. So let's write the query. The query will be select job, average salary from table employee. Then we need to make group on job. So it will be group by job having count star greater than 2. So in this case, first grouping is performed on job column. Then only those groups are selected where more than 2 employees are working in that job. And then finally job and average salary is displayed. In this example, we have to display total salary, maximum, minimum and average salary of employees job wise for department number 20 and display only those rows having average salary greater than 1000. In this case, we have to select job, sum of salary, maximum salary, minimum salary and average salary from employee table. Then first step will be to select only desired record of department number 20 with where clause as shown here. So where department number equal to 20. Then grouping will be made on job field as shown here, group by job. Then having clause will be added to display only those groups where average salary is more than 1000. So this will be the final query. In example number 3, this query is further extended to display the output in descending order of total salary. So the remaining query will be same. First we will select job, sum, maximum, minimum and average salary from employee table where department number is 20. Group by job having average salary greater than 1000. Then order by clause is added to display the records in descending order based on their total salary. Let's execute these queries to understand its implementation. Let us consider employee database having 5 columns: e-number, e-name, job, salary and department number with 10 records, and here we wish to apply grouping and having operations on this database. Let's find total salary paid to employees in each department. This query will display total salary paid to employees in each department as shown here. And in this case, I wish to display only those departments where total salary is more than 1,50,000. In order to select those groups where total salary is more than this amount, we can add having clause as shown here. So by introducing having clause, second group has been removed and it only shows those groups where total salary is more than this value. We can also find out total number of employees working in each department by using this query as shown here.
But in this case, I am only interested in those departments where more than 3 employees are working, and in order to do that, I have to introduce having clause as shown here. In this case, 2 groups has been removed and it only shows a group of department number 30 which qualify this requirement. We can introduce where clause to select desired records before making the group. And in this case, we are only selecting those records in which job title is not professor. And then the count is 2, 3 and 2 in department number 30, 20 and 10 as shown here. Let us select those departments where more than 2 employees are working, excluding job title professor. So then we can add this condition in having clause to display desired record. In this query, we are displaying job, the total salary, maximum, minimum and average salary for each job. Let us exclude the record of some department number in this process. In order to exclude the record of department number 20 in this process, we can add where clause as shown here and the output is modified accordingly. After making these groups on job, I want to select only those job title where average salary is more than 50,000 and to perform this we have to introduce having clause as shown here, and you can check that job title having average salary less than 50,000 has been removed from this output. We can also arrange the output of this query in ascending or descending order on any column with the use of order by clause as shown here. Here we are arranging the output in descending order on the basis of maximum salary as shown here. Here too refers to maximum salary and we are arranging the output in descending order. In this select statement, we have used all the clauses of select statement which include where clause, group by clause, having clause and order by clause to display desired output. And this is all about the demonstration of this concept.
Now let us summarize the concept we have learned in this session. In this session, we have learned the usage of having clause of select statement. And with this, we have completed the concept of group by clause. In group by clause, we have discussed its need and its usage with the use of select statement. We have also discussed the process of grouping on more than one column. We have understood the process of selection of groups with the having clause of select statement. With this, we learn the importance of where clause, group by clause, having clause and order clause of select statement. You can further read more on grouping of data in reading section of week 4. Thanks for watching this video.